Hi all, have a good day. I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video lecture, let us see about the input and output characteristics of common emitter, common base and common collector configurations of a BJT. So first we'll see the common base configuration. So it is derived from the fact that the base is common to both the input and output of the configuration. And also the base is usually the terminal closest to or at the ground potential. All the current directions will refer to conventional function between, and the arrows in all the electronic symbols have a direction defined by this convention. Note that the applied biasing are such as to establish current in the direction indicated for each branch. So this is a diagram which shows the common base configuration for PNP and NPN types. So in the PNP configuration, the N is the base, and in NPN configuration the P is the base, so which is common to both the emitter and the collector as shown here. So to describe the behavior of a common base amplifier, it requires two sets of characteristics. So the input or the driving point characteristics and the output or the collector characteristics. So the output characteristics operate in three regions: active region as defined by the biasing arrangements, and cutoff region where the collector current is 0, and the saturation region of characteristics to the left of VCB is equal to 0 volts. So this is the characteristics of input and output characteristics of the common base configuration. So the input characteristics, as such, for silicon and germanium there is a minimum voltage above which only the transistor will operate. So if it's it may be either 0.3 or 0.7, and until that no current will flow, and after that you will be having the sudden increase in the current as shown in the input characteristics curve. And also when the voltage keeps on increasing, the current value will get get active every year as shown in the figure. Next one is the output characteristics. So this output characteristics, we know there are three regions: cutoff region, active region and saturation region as shown in the figure. So the output characteristic curves clearly indicates this. The first approximation to the relationship between IE and IC in the active region is given by IC is equal to IE. And in the input characteristics, the base emitter voltage should be equal to 0.7. Next one is the common emitter configuration. It is called common emitter since the emitter is in common or reference to both the input and the output terminals. Emitter is usually the terminal closest to or at the ground potential. Almost amplifier design is using a connection of common emitter due to the high gain for current and voltage. Two sets of characteristics are necessary to describe the behavior of common emitter: input and the output parameters, that is base and the collector terminal parameters. So this is the diagram which shows the common emitter configuration of an NP and PNP transistors. So here in both the diagrams, the emitter terminal is commonly grounded between the base and the collector terminals as shown in the figure, and IE is equal to IC plus IB. So this is the input characteristics of a common emitter transistor. So here the IB is in microamperes compared to the milliamperes of IC. IB will flow when VB is greater than 0.7 for silicon and 0.3 for germanium. Before this value, IB will be very small and there will be no current flowing through it. So the base emitter junction will be forward biased. So increasing the voltage VCE will reduce the IB for different values. This is the output characteristics of a common emitter NPN transistor. So for the small VCE voltage, IC increases linearly with increasing of VCE. So VCE, when it is greater than VCE saturation, IC not totally depends on VCE, it becomes a constant. IB will be in microamps is very small ampere to IC in milliamps. Small increase in IB causes a big increase in the current IC. When IB is equal to 0 amps, ICEO occur. Now noticing the value when IC is equal to 0 amps, there is still some value of current that is flowing. Next is the common collector configuration. Here the input characteristics is the variation of the emitter current with the collector base voltage, keeping collector base voltage constant as shown here. So VCE2 is greater than VCE1. And the output characteristics is the variation of the emitter current with the collector emitter voltage, keeping the base current IB as constant. So IB3 is greater than IB2 is greater than IB1. Next was the current transfer characteristics. This is the variation of emitter current with the base current, keeping the collector emitter voltage a constant. So VCE is kept constant here, and the graph is drawn between IB and IE as shown. So this is the tableau column which represents the summary of different transistor configurations. So common base, common collector and common emitter. Common collector is also known as emitter follower. So the voltage gain is high for common base, it is low for common collector and medium for common emitter. Current gain is low for common base, high for common collector and medium for common emitter. Power gain is low for common base, medium for common collector and high for common emitter. Input and output phase relationship is 0 degrees for common base and common collector, and for common emitter alone it is 180 degrees. Input resistance is high for common collector and it is low for common base and it is medium for common emitter. Whereas output resistance is high for common base, low for common collector and medium for common emitter. Let us take up some assessment questions. For a BJT, for common base configuration, the output characteristics are represented by a plot between which of the following parameters. As the output is drawn between VCB and IC. In a BJT, if the collector base junction is reverse biased and the base emitter junction is forward biased, which region is the BJT operated in? So the BJT will be operated in the active region. In a BJT, if the collector base junction and the base emitter junction are both reverse biased, then the BJT will be operating in cutoff region. Thank you for watching this video.